7.3 deals with special cases. So what are binomials that are special cases? Well, we have two instances. We have what we call binomial squares. Binomial, two terms, squared. Well, it's a binomial, x plus 3, quantity squared. So that's a binomial squared. Now, the mistake that most people make here is do not distribute the square. You cannot distribute the square. You cannot distribute it in. It does not, but it does not equal x squared plus 9. That is absolutely incorrect. No. No, it does not. You cannot. This is the exponent, and we have two of these. So if we have two of those, that is seen as x plus 3 times x plus 3 because we have that whole entire piece. And then, because we learned in 7.2 that we do a double distribution, we're going to distribute that x to each piece in the second term, and then we're going to distribute this 3 into each of the pieces in the second binomial. So we have x times x plus x times 3 plus 3 times x plus 3 times 3. This is the green part. This is the blue part. And if we simplify it now, we get x squared plus 3x plus 3x plus 9. And my answer, my correct answer, is x squared plus 6x plus 9. So that is the solution to a binomial square. So that's the first thing we're going to learn about, binomial squares. And then the other one is what we call conjugates. And conjugates, again, are special. They're special because you're going to get something like this, x plus 4, x minus 4. So they're going to look like, they're kind of like opposites. They're opposites, and they're not exactly because the x's are the same, but they kind of feel like opposites. So we still take the first term and distribute it. We're still doing double distribution. We take the second term and distribute, and let's see what happens. So we get x times x plus x times negative 4 plus 4 times x plus 4 times 4. Again, this is the first distribution. This is the second distribution. Let's simplify that. X times x is x squared. X times negative 4 is negative 4x. 4 times x is 4x. And 4, oh, I made a mistake there. 4 times negative 4 is negative 16. My middle two terms, they end up canceling each other. And you get two terms. This is the first time that our solution has been only two terms. So when we did 7.2 and all of that double distribution, we always ended up with 3 terms. And this is the first time where our 2 of our terms in there will cancel. So that'll be an interesting thing to see if you start seeing patterns. And I ask you, do you notice a pattern? Yeah. Rewrite the base times itself twice, then FOIL or double distribution. So this becomes x plus 2 times x plus 2. And we'll distribute, just like we did in 7.2. Distribute that, and what do we get? We get x times x plus x times 2 plus 2 times x plus 2 times 2. X squared plus 2x plus 2x plus 4. My 2x and 2x are like terms, so we get x squared plus 4x plus 4. Make sure it's in standard form. It is. Okay, that would be our first answer. So those are the little notes here. r minus 1 quantity squared. So we have r minus 1 times the quantity r minus 1. The base times itself twice. And we get r times r plus r times negative 1 minus 1 times r minus 1 times negative 1. R times r is r squared minus r plus 1, r squared minus 2r plus 1. Okay. Ooh, okay, now it's a positive. X plus 1, x plus 1. X times x plus x times 1 plus 1 times x plus 1 times 1. X times x, x times 1, 1 times x, and 1 times 1. X squared plus 2x plus 1. Okay, good. I got this just like 7-2. Super easy. We just have one beginning step is to write out that binomial into the product of two of the same thing. So k times k plus k times 4 plus 4 times k plus 4 times 4. K times k is k squared. K times 4 is 4k. 4 times k is 4k. 4 times 4 is 16. K squared plus 8k plus 16. These are getting easy. I like it. I see a nice little similarities to my double distribution. And I'm getting good at my times tables and multiplying single digit numbers. X times x, x times negative 8, negative 8 times x, and negative 8 times negative 8 is positive 64. X squared minus 16x plus 64. R minus 7, r minus 7, r times r plus r times negative 7 minus 7 times r minus 7 times negative 7. R times r is r squared. R times negative 7 is negative 7r. Negative 7 times r is negative 7r. Negative 7 times negative 7 is positive 49. R squared minus 14r plus 49. All right, x minus 4, x minus 4. Have I already done this? X times x plus x times negative 4 minus 4 times x minus 4 times negative 4. I kind of think I've done this. Maybe I did this as my practice one. X squared minus 8x plus 16. Oh, here we go. We knew it was coming. All right, coefficient of my first term now is not 1. It actually has a coefficient greater than 1, but that doesn't change anything. It's still 5b times 8 times 5b plus 8. And this is very similar to the second half of 7.2 when we had coefficients to that first term. So it's still 5b times 5b and 5b times 8 and 8 times 5b and 8 times 8. Nothing changes just because the coefficient is there. That's 5b times 5b plus 5b times 8 plus 8 times 5b plus 8 times 8. 5b times 5b is 25b squared. 5b times 8 is 40b. 8 times 5b is 40b. And 8 times 8 is 64. Let's combine those like terms in the middle. 4b times 4b is 80b plus 64. That wasn't bad. Remember to always rewrite it out to ensure accuracy. There's no rush here. 4p times 4p plus 4p times negative 3 minus 3 times 4p minus 3 times negative 3. 4p times 4p is 16p squared minus 12p plus 9. 16p squared minus 24p plus 9. 8b plus 6 times 8b plus 6. That took 1 second. Okay, maybe 2. 8b times 8b plus 8b times 6 plus 6 times 8b plus 6 times 6. That probably took 10 seconds. 8b times 8b is 64b squared. 8b times 6, 6 times 8 is 48b. And 6 times 8b is 48b. And 6 times 6 is 36. 64b squared, 48 and 48 is 96b plus 36. All right, that's bigger numbers, but we got this. 3v minus 2, 3v minus 2. 3v times 3v, 3v minus 2 times negative 2, minus 2 times 3v, negative 2 times negative 2. 9v squared minus 6v plus 4. 9v squared minus 12v plus 4. 5b minus 3 times the quantity 5b minus 3. 5b times 5b plus 5b times negative 3 minus 3 times 5b, negative 3 times negative 3. 25b squared minus 15b plus 9. 25b squared minus 30b plus 9. That's not a very good 9. 9. 9's a hard one. Oh, 2 variables. Okay. All right. M plus 2n times m plus 2n. Does it get harder? Nope. You're still distributing this to this, and you're still distributing this to this. It doesn't change. So we have m times m plus m times 2n plus 2n times m plus 2n times 2n. M times m, m squared. M times 2n, 2mn. Don't forget alphabetical order. Alpha order. And 2n times m is 2mn. And 2n times 2n is 4n squared. All right, we have like terms. So that is m squared plus 4mn plus 4n squared. Now, is it in standard form? Standard form. So first term, first term, first term. This is m squared. It comes before m to the first. So we know those two. And now, so we know that's going to be the first term. Let's look at the first and the first. Okay, this is m is going to come before n. So this term will always come before. Even though this is n squared and this is n, this term has an m. Alphabetical order. M is always going to come before n. M, alpha order. So this is in standard form. Hopefully you saw that. Whoa! All right. A little bit bigger numbers, 3x minus 3y times the quantity 3x minus 3y. So we have 3x times 3x plus 3x times negative 3y minus 3y times 3x minus 3y times negative 3y. 3x times 3x is 9x squared. 3x times negative 3y is negative 9xy. Negative 3y times 3x is negative 9xy. And negative 3y times negative 3 is positive 9y squared. Woo! We'll see how many people get this one right. This is a good one. Oh, yes. Good. So there it is. Perfect. Okay. Step 2. That was just the first 14. Those were multiplying binomial squares. Binomial squares, 2 terms being squared. These are called the conjugates. These are conjugates. They are very similar, except they have different signs in between the 2 terms. That's why I call them kind of opposites. All right, we still do the same thing. B times B plus B times 7 minus 7 times B minus 7 times 7. We're still doing the distribution, double distribution, and negative, we're going to distribute the negative 7. B times B, B squared, B times 7, 7B, negative 7 times B, negative 7B, negative 7 times 7 is negative 49. My 2 terms here, they cancel, and you get B squared minus 49. So conjugates are going to produce 2 terms. R times R plus R times negative 5 plus 5 times R plus 5 times negative 5. R times R is R squared. R times negative 5 is negative 5R. 5 times R is 5R. 5 times negative 5 is negative 20. Whoa. Negative 25. And we get R squared minus 25. X times X plus X times 2 minus 2 times X minus 2 times 2. X squared plus 2X minus 2X minus 4. My middle 2 terms cancel. X squared minus 4. V times V plus V times 8 minus 8 times V minus 8 times 8. V squared plus 8V minus 8V minus 64. V squared minus 64. V times V plus V times 5 minus 5 times V minus 5 times 5. I feel like I've done 5s already. V squared plus 5V minus 5V minus 25. V squared minus 25. Definitely done 5s. I think I've already done 1s too. V times V plus V times negative 1 plus 1 times V plus 1 times negative 1. V times V is V squared. V times negative 1 is negative V. 1 times V is positive V. 1 times negative 1 is negative 1. V squared minus 1. I don't think we've done that one. That one's a good one. N times N plus N times 4 minus 4 times N minus 4 times 4. N squared plus 4N minus 4N minus 16. N squared minus 16. Oh, coefficients. We changed it up a little bit. 3x times 3x plus 3x times 6 minus 6 times 3x, negative 6 times 6. 3x times 3x is 9x squared. 3x times 6 is 18x. Negative 6 times 3 is negative 18x. Negative 6 times 6 is negative 36. Those 2 middle terms still cancel. Positive 18x, negative 18x makes 0. And you get 9x squared minus 36. 3n times 3n plus 3n times negative 1 plus 1 times 3n plus 1 times negative 1. 3n times 3n, 9n squared. 3n times negative 1, negative 3n. 1 times 3n, positive 3n. 1 times negative 1, negative 1. You're left with 9n squared minus 1. Okay. Conjugates always produce two terms. 8x times 8x plus 8x times 6 minus 6 times 8x minus 6 times 6. 64x squared plus 48x minus 48x minus 36. 64x squared minus 36. Oh, that's good. They switched. 6p times 6p plus 6p times 8 minus 8 times 6p and minus 8 times 8. 6p times 6p is 36p squared. 6 times 8 is 48p again. Negative 48p and negative 64. We get 36p squared minus 64. Very similar to the problem we just had. They just flipped their coefficients. 6n times 6n plus 6n times 4 minus 4 times 6n minus 4 times 4. 36n squared plus 24n minus 24n minus 16. 36n squared minus 16. Just when I was like, yeah, I think I got this. Oh, they threw two variables in there. Doesn't change. X times x plus x times 2y minus 2y times x minus 2y times 2y. X times x, x squared, x times 2y plus 2xy, alphabetical order. Negative 2y times x is negative 2xy, not 2yx, alphabetical order. And then that's going to be minus 4y squared. These cancel. 2xy and negative 2xy are like terms. They have the same variables to the same exponent. You combine their coefficients. 2 and negative 2 makes 0. So you're left with x squared minus 4y squared. I like that. And what I think is the last one, 3u times 3u plus 3u times 2v minus 2v times 3u minus 2v times 2v. Somebody asked me, Mr. Matt, can you not do u's and v's? Well, they're in the alphabet. They're going to be used. 3u times 3u is 9u squared. 3u times 2v is 6uv. Negative 2v times 3u is negative 6uv. And negative 2v times 2v is negative 4v squared. 9u squared minus 4v squared. Write your u's and v's appropriately. Boom. That's it. Good one. Those are special cases, special binomials. And the two special binomials are binomial squares and conjugates. Good luck.